On this slide, you can see the simple scheme of our machine learning model. As any machine learning model for regression task, it has the predictors and target variable. Our target variable is soil organic carbon content, initial soil organic carbon content. And our predictors consist from 4 different types. Predictors based on digital elevation map, satellite-based predictors, soil predictors, and climate predictors. And with the following slides, we show you some examples of these predictors. Here, you can see some predictors generated from digital elevation map with Saga and GrassGIS modules. Usually, we split this type of predictors in 3 classes: topographic, hydrological, and solar predictors. And here a couple examples of these predictors. The first one is topological, so-called vector ruggedness. And this vector ruggedness measure provides a way to measure terrain ruggedness. Slope and aspect are captured into a single measure and used to decouple terrain ruggedness from just slope or just elevation. The next one, topo parameter, is plane form curvature. This is perpendicular to the direction of the maximum slope. Next, flow accumulation contains the absolute value of the amount of overland flow that traverses each cell. The topographic wetness index. This index is really steady state wetness index and is highly correlated with several soil attributes such as horizon depth, silt percentage, phosphorus, etc. The next is solar predictors, beam irradiance and ground reflected, which also can be pretty helpful for initial soil organic carbon estimation. As for example, beam irradiance has a significantly higher variability in space and time in comparison to global irradiance, and helps to describe the canopy variation, and as a result, can describe the potential of soil organic carbon content. The next type of predictors is satellite-based. And here's the example of optical predictor. And one of the important things, when you generate predictors from the so-called high variable or extreme variable parameters in time, it is necessary to remember and note that organic carbon in the soil itself is not extremely variable in time. And as a rule, you can observe the changes of soil organic carbon content in time step of 6 months up to 5 years and more. So just to cover the variability of soil organic carbon content, we have to fit our predictors to the same time step of variability. This is very important thing. In this example, to create optical predictor in the correct way, based on vegetation index, NDRE, for example, we take the maximum value per each year of at least 3 or 5 years period prior to ground sampling and average these maximum values. In such approach, we align our predictors with temporal variability of soil organic carbon content. The soil type of predictors. For this type of predictors, we use different soil properties as well as soil type. And based on FAO soil classification map, the territory of Australia covered with 40 types of soil On this slide, with green color selected the most widespread soil types, which cover more than 85% of territory of Australia. And to clarify some soil parameters, we also use simple linear regression based on ground samples and open source data. Yes, and last but not least, of course, the climate type of predictors. And here the same approach as with satellite-based example. In order to align our weather parameters with soil organic carbon temporal variability, again, we have to use so-called two-level averaging method. In this example, we have 3 years period. For each year, we take the average of mean temperature per each season, with further averaging by the whole period. And such method applied to any weather parameters, except precipitation. In case of rainfall, we take the sum instead of mean.